All right, now we're going to do finding the area of the region between, and here I've got the function, the cube root of x and g of x equals x. All right, so the first thing that you'd want to do is you'd want to go ahead and put this into Desmos. For cube root of x, probably the easiest way to do that is to say x to the 1/3, right? That would give me a cube root. Okay. You probably also are going to need to change the window so I can zoom in, because what's going to happen is that the cube root function looks like this. Okay. And then y equals x is going to look like this and this. So you're going to have to really zoom in to see that. Okay. So what's happening is that we have two regions that are trapped, which are there and here. And I didn't draw it very well, but they're actually going to be symmetric, meaning that they're going to be the exact same size, just flipped. Okay. So what I want to do is I want to find the area of this region. So notice that the top function is the cube root. Okay, so the top of this is the cube root. The bottom is x. Okay, so top function minus bottom. By the way, if you ever get confused, if you just draw a line down, whichever one I hit first is the top function, whichever one I hit second is the bottom function. All right, awesome. Now this example is harder than the last one because they didn't tell me where to integrate from. So that's why it's important to make sure that we use Desmos or another graphing tool, and I find where they cross. And where they're crossing is at 0, 0, so x is 0. And then over here they're crossing at 1, 1, so x is 1. So if I integrate this from x is 0 to x is 1, I'm going to get this integral, and this is going to find my area. Okay, now I want to find total area, so what I'm going to do is once I get this answer, I'm just going to double it so I can get the symmetric piece that's over here. Okay, well, I'm ready to integrate almost. I need to rewrite this as x to the 1/3. And then now I should be ready to do the power rule, so let's see what I get. So I would get, let's see, integration has a guide, add a 1 and then divide, but that's going to flip. And I'm so excited that I made up this problem. It's a little gross. Okay, now the good news. 1 to any power, it's 1. 0 to any power, 0. Okay, so what's going to happen here is I'm going to get 3/4 minus 1/2 when I plug in the 1. And then I'm going to get a whole bunch of zeros. Awesome. So 3/4 minus 1/2 is 3/4 minus 2/4. So this is just going to be 1/4. So this 1/4 is the area of that one sliver. I want 2 of them. So I want 2 times 1/4. So my answer here is going to be 1/2. Will give me the total area. All right. I hope that example helped.